Welcome to the ML India podcast, where we talk to people in India that are doing really cool things with data. I'm Karmanya.
And I'm Hitkul.
Today, we're talking to Dr Monojit Choudhry about linguistics, NLP, and industrial research in India. Monojit did his bachelor's and PhD at IIT Kharagpur and is a principal researcher at MSR India. In addition to being a prolific author at premier venues, he's an eminent expert on low resource languages and natural language understanding. Monojit, do you want to give us like a very quick introduction, just for the audience, perhaps?
Sure, Karmanya and Hitkul. First of all, thanks for inviting me for this podcast, and I believe this is the very first issue of the podcast. So even a bigger thanks for thinking about me as the opening batsman for your podcast. So to give an introduction about myself, I'm a researcher at Microsoft Research Lab India and have been working here for last 14 years. Before that, I did my undergrad and PhD both from IIT Kharagpur and in computer science. I have been working since my final year undergrad times. I have been working mostly in natural language processing, but I would say more broadly, I have been working on artificial intelligence and cognitive science. For instance, I have looked at music, I have looked at psycholinguistics. So not only natural language processing, so to say, but more broadly computation plus cognition. And there are a whole bunch of things within that arena that interests me. Yeah, and then within, let's say, the world of NLP, the most specific uh, interests that I have or I have been exploring lately are one is in the area of what we call code mixing or code switching, where people mix multiple languages in a single conversation or utterance, and how to process it, why do people do it, and all. So that has been one area of research in our lab for last, let's say, 5 6 years. The other area which I have been interested in, and people in our lab, we have been working on it for quite some time, is this issue of low resource languages. As we all know, like a lot of Indian languages have very little resources or data, so as to say, and data is very, very essential for building systems, especially machine learning systems. What do we do when we don't have enough data? What are the different kinds of problems, challenges, and what are potential solutions? And how can we help the community who speak those languages? And that's the broader theme of the other area I'm interested in. So broadly these two, but yeah, as I said, there are also specific interests. For instance, I'm right now also looking at natural language understanding and natural language inferencing, which looks like you know a very intriguing area, because on one hand we have these systems like GPT-3, which seems to you know be able to do fantastic things which we couldn't have even imagined few months back before GPT-3 came, right? Or a couple of years ago, we would not have, I mean, nobody would have even dreamed of a machine which would have such capabilities. So that's a great achievement. But on the other hand, we also feel very, if you look a little deeply into these systems, probe a little deeper, more and more people are showing, even though it can do fantastic things, it also fails on very, very simple things. So what's really going on? So that makes natural language understanding and one particular version or task, which is we call natural language inferencing, a very interesting area and a very active area of research right now. And I'm also kind of exploring that a bit.
Awesome. I think that's definitely really interesting. I remember from this year's ACL, particularly, there was the checklist paper where they went in and they looked at a bunch of very standard off the shelf NLP models, and they were like, how well do they respond to what we would consider normal human behavior, right? So, like a sentiment model responding to having the presence of this was not good versus this was good in the sentence and stuff like that. So, I think that's definitely like something that's becoming very popular today.
Yeah, definitely.
So, on that topic, perhaps, what did you had two papers at ACL, right? The glucose paper, and then I think the diversity of languages paper. What were your experiences with like virtual ACL? Did you like it? Did you find that the ability to interact with people was a little bit limited?
I would say I have mixed kind of takeaways, but mostly positive. Uh, so let me talk on the positive sides what I really enjoyed this time in ACL. So one is definitely, since there was no travel and registration fee was also quite low because it was all virtual. So the scope for a lot of people, especially from countries like India, South Asia, and all, right, had a uh, they had a scope to participate in ACL, which usually is hard because you need a huge funding to participate. And I did see that too. A lot of Indian students, for example, who didn't have a paper was still there. And I think this is very important because if you already have a paper in a conference, you know how to write paper for that conference, or what's going on in the area, right? And that's how we manage to write a paper. So better thing is to get the exposure before you start working so that you understand whether you like the field or not. I'm talking mostly from the perspective of students here. So I think for students, it was a great opportunity to, listen to the, thought leaders in an area of research and try to, build their own mind in what they want to do research in, what are the interesting problems and all. So this was one big positive. The second thing which I liked was this format, which had these 12-minute videos followed by an always open asynchronous chat. So, since it was asynchronous, both the chat and the videos were all available. I could go and watch them at any time. So, unlike in a real ACL where there are parallel sessions going on and I have to choose between, let's say, four parallel papers, I can only attend one, and sometimes it might be that I'm too tired right now because I have already attended three sessions and I don't want to attend this fourth one, but the fourth one has this really interesting paper I want to attend. So all these issues and balancing between them, running after, session from session to session and so on, those issues were not there. I could pace my viewing of these presentations. So whenever I had time, I would view, and it was 12 minutes, so I could view them in between my regular meetings also, or day-to-day work and everything. So it was more relaxed. And then whenever I had questions, I could just go on the chat and ask people questions, and they would answer. Now here also there was a great thing in real ACL. After the talk, there is only time for like 2 or 3 questions. That's true for most conferences, right? A 12-minute or 15-minute talk followed by 3 minutes of Q&A. Now 3 minutes, maximum three questions can be answered, and there are so many people waiting to answer questions, sorry, ask questions. uh, Whereas here it wasn't like that, right? There was no limit on how many questions could be asked. And, even you didn't have to answer it in 3 minutes. You could have gone back, come back later and answered it at your convenient time and so on. If there are multiple authors in a paper, the paper, authors could share the load of answering questions between them. So all these were very positive, and I saw a very, I mean, at least from my point of view, I could engage a lot better with the authors of different papers with whom I think if it was a physical ACL, it would have been much less probable. Um, and then they had this, face to face slots where you could directly go and interact with the authors, and authors will be present. So these were like 1 hour slots, two such slots. These were also useful, but less so, I would say, because of time zone differences. So for instance, we are in India, so we prefer time zones which are not like beyond 10 p.m. or before 6 a.m. in by Indian time. But then what would mean is whatever time we got, which was, let's say, 1 sorry, I think it was 11 a.m. in the morning, so it will be 11 p.m. somebody in the Pacific time zone. So for them to come and attend that face to face session was hard. So their time zone differences mattered. And we could see that, people who came and attended, their distribution, where they were from, which part of the world they are from, you could clearly see time zone really affected that. But having said that, because of the asynchronous chat possible, this was not a big issue. The only negative, I would say, is this what we call the corridor chats, or the over coffee discussions and all, which I really missed. Even though ACL did have these social channels and the chat had different channels and people did engage, but I found it a little overwhelming because there were so many channels going on, and I didn't have any particular person. If I knew whom to meet to or talk to or which paper to attend, that's easy, I can always do it. But casually bumping onto somebody and started talking, discovering an old friend in the crowd, those things were very I mean, was difficult. I don't, at least for me, it didn't happen. But I did get a lot of ping from a lot of people, mostly students from all over the world, who I think were using this chat more effectively than I could. Yeah, so for some people that might work well as well. Yeah, I think overall it was very good, and very good opportunity for let's say Indian students to attend and interact with thought leaders in the field.
Yeah, I guess like being in Indian academia, especially like for students, it has always been like now most conferences have these $1,000 registration fees, plus mostly traveling to US or European countries. It always is a big challenge that how do you source the funding, or how many people from the lab can go and actually attend. And especially like not having a paper and going there is almost not even in like works most of the times in India. But I guess that would really help. Virtual conferences would really help that situation.
Definitely, yep.
So going in more into some of your work. So you have majorly worked a lot in code mix and low resource languages. So especially considering low resource NLP, what do you think are some of the major challenges faced in this area, especially when we talk about, let's say, Indian or Asian languages?
As I already mentioned in the beginning, right? So it's a very interesting uh, juncture through which NLP is going right now. So, because of this, let me call it the deep revolution that has happened in NLP, uh, we can now do things which were unthinkable even few years ago, sometimes even few months ago. So there is lot of very fascinating stuff happening. No, denial in that. Now, of course, a lot of people are asking whether we are making real progress in language understanding and tough questions like that. My answer to that would be, perhaps not, or perhaps yes. Certainly, we are making some progress, and there is a lot of questions that needs to be answered, which is good. As a researcher, questions are always good to have, right? So there are lots of open questions, whether the systems are really understanding what they are really understanding, and which we will look into that. And so overall, I am very positive about this deep revolution in NLP that has happened. But then there is one big side effect that also comes with it. The side effect is often these systems require a lot of data to train a model. Now, if you look at how NLP has progressed over the years, the earliest models in natural language processing in 1960s, 70s, even till 80s were mostly rule based. You really did not require a lot of training data in a language. Then came the machine learning models, early era of machine learning, 90s and all. So you required data, but the data wasn't, the data requirements were not too heavy. So it was possible to create these data sets for a large number of languages. Even though, I mean, it might not have happened for various historical reasons. It did not happen for Indian languages that well, even at that time. But nevertheless, it was possible. But what happened is when we started building resources for, let's say, Indian languages, thinking of what is the need for today's systems, by the time we had would have built the resource, which may took 5 years. In 5 years, the technology would have progressed so far that those resources, those amount, would be minuscule. and the technology would require a lot more resources. And with deep learning, this resource requirement is huge. So all this, hype or hue and cry about GPT-3 is, if you think of it, basically what goes under GPT-3, the basic architecture is not revolutionary. We knew about these architectures, just that it is bigger and trained on more data. So essentially, several hundred billions of tokens of English, right? So the question is, can we build that kind of data sets for Indian languages, or any language in the world? I will mostly talk about Indian languages because we are talking in the Indian context. But yeah, just keep it in your mind that this applies to a very large number of languages in the world, which is essentially what we show in this linguistic diversity paper. That if you look at the languages across the world, there are only 5 to 7 languages which has a lot of resources, and therefore you can build GPT-3 like technology for those. Probably GPT-3 is an extreme example, right? Probably only English has that much resources, but even if you think of Arabic, Spanish, and few other languages, you can build cutting edge NLP technology for them as well. But then only 5 to 7 languages, whereas the world has 5,000 to 7,000 languages. So it's 1,000th of that, right? What about the rest of the languages? And if you look at them, there is a nice, or rather unfortunate, power law distribution. So a very large number of languages have no resources, and and there are languages in the middle also. Now, if we categorize the languages in terms of how much resources they have, so there are two kinds of resources that are important. You need what we call labeled data. So this might be, let's say you want to do part of speech tagging or sentiment, let's say sentiment analysis. So you would have sentences and the labels for the sentiments, right? Whether it's positive or negative and so on. So that's labeled data. And then unlabeled data. It's just, let's say, running text or corpora in those languages. Now, you would, imagine, and rightly so, that getting running text is much easier than getting labeled data, because you need a human intervention to label the data, which is more time and effort intensive. And one, again, good thing about neural nets is it has made requirements for labeled data less. So now we can do well. I mean, we have this multilingual zero shot transfer kind of approaches where with very little or almost no label data, we can still achieve good success, good accuracy in a particular language, let's say Hindi, in sentiment analysis, provided we have lots of label data in some other language, let's say English in this case. However, we need at least unlabeled data for Hindi, and we need a lot of unlabeled data to do well. Now, then the question is how much labeled and unlabeled data we have across the world's languages, right? And what we saw is you can look at the languages and neatly put them into five or six categories. So what we call category 5, or the winners, are these 5 or 7 languages which has most of the resources, both labeled and unlabeled. And category 0 are the languages which has unfortunately kind of nothing. So they are left behind. And the number of languages in the category 0 is 88% of world's languages, which is a huge amount, right? And the number of speakers speaking those languages is close to, I don't forget the exact number, between 1 and 2 billion. So it's again 1/6 or let's say 1/7 of world's population. So that's a huge problem of resource distribution. And even with the deep methods, we really can't do anything about this left behinds. Now, coming specifically to Indian languages, right? Hindi is in the second level, like level 4, which we call underdogs. So Hindi has enough resources and everything looks quite promising for Hindi. Hindi can be easily pushed to have the best technologies within few years, or if we work a little more on Hindi. So I don't think Hindi has a problem. If you look at the next Indian set of Indian languages in terms of who are faring well, we call them the category 3, or the rising stars. Why rising stars? Because they have a lot of unlabeled data, and given the current techniques which work with a lot of unlabeled data, can only leverage unlabeled data. So for them, this deep revolution is really a God sent thing, right? A miracle. So they will now suddenly look very technologies will suddenly start appearing in those languages. Examples are, I would say, Bengali, Tamil. So these are like rising stars. But then you go to, and probably only Bengali and Tamil. Then you go to the rest, of the languages. Let's say Marathi, Telugu, Assamese. They are either in level 2 or level 1, because even the amount of unlabeled data is not enough, and labeled data, of course, is very little. And a majority, these are, I'm talking still within the 22 scheduled languages, right? And if in 22 scheduled languages only 3 languages come to promising rising stars or underdogs, everything else is below. And if you look at the other Indian languages which are not in the list of these 22 official languages, they are nowhere in the map. They are in category 0, but there are millions and millions of speakers. For instance, a language like Gondi has again, several million speakers. Now, uh, how do you bring the benefit of technology for these people and make create an environment for financial and digital inclusion for them? Because unless you support their language on the mobile phones that they use, how would you dream of a digital India? How would they be included? Now, this is a big challenge, I think. And other than, of course, I just talked about the language resource distribution angle of it. There is also another angle, which is what kind of technology is needed for what kind of communities, right? So I can imagine that one of the hardest to build technologies right now is natural language inferencing or chatbots, which can do a free flow chat without on anything on earth. Now those kind of things are very hard to build and are possible, or we are getting there for languages like English. Even for Hindi, they are very difficult. But maybe we can build or try to build something. We can't even imagine building these things for, let's say, Marathi right today, or Gondi. Forget about it. Uh, but one good thing is, do we really need such chatbots for Gondi or Marathi? Are there other technologies which are also equally important and can be built with less amount of resources, and probably will bring in digital inclusion much better than building fancy chatbots? So this is another dimension, like what the speaker communities need, understanding that. And I don't think NLP community has done enough research there, because NLP community has always been mostly furthering the field, right? What is the hardest problems in NLP today, and I want to work on that and solve those problems. I really don't look at which languages even today don't have, let's say, a good text prediction on their phones, and what is the simplest methods of building text predictions when you don't have enough data to learn these predictive models. So these are questions which probably are not that important in the NLP world, but very, very important for that particular language community. So that is the other challenge, right? Bringing those communities and the needs of those communities in the NLP map, so that people who are working on these are also aware and start thinking about these problems. Let me stop there, because I think it's a topic where I can go on and on, but I would like to know your reaction, and what would you like to know more about it, or other things.
So that's really interesting, and I think you kind of answered a couple of questions that I had without like implicitly me asking them or explicitly me asking them. But one thing I would like to maybe talk to you or probe you a little bit on is specifically transfer learning. So, assuming that where our goal or our aim is to hit, perhaps, as you said, slightly less complicated or cutting edge tasks for these low resource languages, to what extent does like multilingual transfer learning help, right? Or like where you essentially you pre-train on, say, like Hindi or English or a language which has a lot of resources available, and then you transfer that over perhaps to Marathi or Telugu or something like that.
Especially, I guess, in cases of languages like Hindi versus Marathi or Hindi versus Gujarati, where there are even much more similarities in the way the languages are set up compared to, I guess, something like Hindi versus Telugu, which are still slightly more different.
This is actually a very, very interesting question, and something which we are right now working on. I will tell you why this is an interesting question. I mean, of course, it is interesting because you can help those low resource languages in certain ways, but even otherwise also this is interesting because you see this zero shot cross-lingual transfer that you are referring to, that uh, came out. It's a pretty recent technique, right? It came out around 2018 with Mbert now, and was perfected around 2019. So just a year and a half old or so, right? So how much do we know about these things is a good question to ask. And of course, there is a lot of hype and a lot of people are talking about this. But we know that if we train with Hindi, it will transfer well on Gujarati. Whereas if we train with English, it won't transfer well on Gujarati. Is it true? And especially given that I might have a lot of data for English, whereas I may not have that much data for Hindi. Still, does it make sense to train with Hindi and transfer to Gujarati and not English? So there are lots of these kind of questions. And the simple answer is we don't know the answer. And nobody has done those experiments. And I will tell you what we know so far. So when we started probing, we had exactly the same question that you asked. And when we started probing into like what do people know about this multilingual transfers, when do they happen well and all, we see most of the reported successes are on this on a benchmark called glue in which specifically there is a data NLI data set and its cross-lingual version, it's called XNLI. So how many languages does XNLI has in its test set? Only 15. And of these 15 languages, how many Indian languages are there? Only two, Hindi and Urdu. And Hindi and Urdu are essentially the same languages, right? Linguistically. They are just written differently, but structurally they are, I mean, they use different scripts, but structurally they are pretty similar, exactly the same language almost. So we don't have representation from any other languages from India. What about other languages from Africa and all? We have Swahili and we have Vietnamese and another Asian language. And of course, Japanese, Chinese is there. But everything else is mostly European language. I might have missed one or two here and there. So if you see, all our or most of our conclusions so far and experiments are based on these few languages. Now, will it generalize to a language like Gujarati or Gondi or, let's say Zulu? Nobody knows. Unless we do these experiments, we don't know because neural nets are almost like black boxes, right? It's very hard to make predictions about them uh, theoretically. You have to mostly run the experiments and see what happens. So people have been asking the same question or similar questions and they have started working on it. So how they are working, so there are two lines of research. So one line of research is where you get a lot of you know you build a lot of test data across languages. Training data is easy because here in multilingual zero shot you just need unlabeled data, so Wikipedia is a good source. So mbert actually supports 104 languages today. Multilingual BERT has that many languages, including many Indian languages. So even Marathi, let's say. So if you want to do a zero shot transfer on Marathi or Bengali or something, you just need training data for those languages and you can try. But how many languages are you going to try? And when you try, you would see some languages work well, some don't work. For some it works well, some it doesn't work well. Why? So we have guesses or speculations, but we don't know for sure if this is the case. So one speculation which you were also trying to refer to is called amount of shared vocabulary between two languages. So if I have two languages which have a lot of common words, then by virtue of having those common words, training on one might help the other. So in Indian context, example would be Hindi Marathi because they also use the same script, right? Hindi Gujarati might have a lot of common word, but since the script is different, for from the neural nets perspective, there will still be different words. But for Hindi, Marathi, or let's say for English and German, English and French, you would have lots of common vocabulary, shared vocabulary. Now, does it help? There is a line of research which says it helps, and there is also very recent papers which says it doesn't hurt, but it is really not that important. So in that case, there is no particular advantage of having shared vocabulary, if that is true. Then the other thing which people have been talking about is structural similarity, which is true for Gujarati and Hindi, let's say, or Bangla and Odia, where the grammatical structure is very similar. They also share a lot of vocabulary, but as I said, because of script differences, vocabulary, unless you do something special, mapping the vocabulary to a similar code space or font script space, uh, it won't be directly useful, right? But at least structure, and it has been argued that somehow these multilingual models work by learning something fundamental about linguistic structures. If this is true, if you train with a lot of Hindi, it should help Gujarati. Now, is it true? And what else do we know? Why it is true and how it learns that structure and all? So all these questions, I would say, we are just kind of scratching the surface of it. So we are trying to understand them. Uh, Gut feeling everybody has is exactly what you said, that if you train with Hindi, it will help Gujarati. And there is some empirical observations which people have reported around that. But I think a lot of research is required to really see what exactly helps and what exactly hurts. The only thing I will add before we move on to another topic maybe is that uh, one thing we have observed is if you have less monolingual data to train with uh, a particular language. So let's say when I was training with unlabeled data, I had very little Gujarati data. Unfortunately, in that case, the Gujarati model will be very unstable. So what happens is, suppose now you are training more with Vietnamese data, suddenly your Gujarati accuracy might start suffering for no apparent reason. Gujarati and Vietnamese has nothing in common, no vocabulary sharing. You haven't even touched the Gujarati model, right? But since it's a common shared model for all languages, so therefore, some weird, I would say, effects happen. We don't know exactly why these happens or how to disentangle them, but they do happen. And the models or languages which have very little data to start with, these models are less robust and they suffer more when you train with other languages. So again, there are a lot of interesting open research problems there also. So to sum up, yes, it's promising direction, but more research is needed before we can make such claims.
Definitely, this is really interesting. And I guess the more interesting part, which I personally like, is the velocity of this research. I remember talking to Karmanya maybe a year and a half ago, when BERT and language models was a new thing, that there was no multilingual language model. And just in a year, we have so many, at least in work experiments going on, which is like, I think, a great sign for low resource languages. From here, I would like to segue into another, so to say, domain, at least in context of the goal of the research, which you do is social computing. Uh, though a lot of NLP code mixing and low resource languages, I guess, is used very regularly in social computing for the actual implementation of the research. I believe there is a very small community of social computing researchers, especially in India, doing things specifically for society and computing. So, what are some line of research which you are excited about? I recently saw your paper on Indian elections, and you recently had ICWSM paper on mental health. But what do you think are some of the interesting problems to tackle, and how do they actually translate to Indian scenario in terms of products or public policy, which can actually be delivered to society in coming years?
When you said no that there is a lot of things that can be done in social computing in India and there are not enough groups working on it, the immediate question that came to my mind was which sub area or area of computer science or science in general we have enough people working in India. Unfortunately none, unfortunately none. See, one of my colleagues says this always. He's an his name is Swami Manohar, Professor Swami Manohar. He was in ISC before. Uh, he's the Simputer man of India. Like he, along with three of his colleagues, had come up with this Simputer, which was one very interesting breakthrough in not only the history of Indian computing, but also in social computing or socially useful computing. Basically, it was a handheld device and all. So what he says, the reason I brought his reference here is he always says India has so many problems, which India and South Asia in general, and even more generically speaking, global South has so many rich problems that people have not even looked at maybe up 1% of that. So when you talk about social computing in India, if you look at I mean, it's such a big topic that I don't know where to start and where to end, right? But let me just take one example, which I'm very familiar with, which is code mixing. So when we started working on code mixing, like people mix languages, which languages people mix, why do people mix languages? And of course there is research in linguistics there, but research and large scale studies computationally wasn't there when we started working, let's say 5 years ago. And then we saw that, if you look at just any social media, be it Facebook, be it Twitter, be it Reddit, any platform you look at, and any Indians, group of Indians talking, they will immediately switch to code switching. I mean, start code switching, mixing languages. And now it's such a wealthy source of data, right? Such a rich source of data, and you can do so many different kinds of research. Now, of course, if I am the only person, I mean, our group is the only group working, and maybe there is one more group. I know Professor Animesh Mukherjee in IIT Kharagpur and Professor Niloy Ganguly. Their group does some very interesting research in social computing. I know, in Triple IT Delhi, PK does very interesting stuff in social computing. So if you look at these isolated groups, maybe 10 of them across India, what kind of things they have done, the number of questions are in thousands, and how many 10 groups can tackle, right? And so there is a tremendous scope of research here, understanding how the uh, Indian and the South Asian society works in terms of uh, social interactions, languages, in terms of ethics. For instance, in privacy, I hear a lot of discussion these days about how the notion of privacy itself is so different in the East, especially in Indian context, than that in the Western concept. Or even fairness, right? When people talk of, let's say, word embeddings are unfair because there is you can show certain gender associations, which shouldn't be there ideally. So, for instance, doctor is closer to men, whereas nurse is closer to women in the word embedding space. Of course, it's there in the data, therefore it's learning, but it's not ideal. So how do you debias them? Now, if you look at the Indian context, right, do you see the similar kind of biases? The answer typically is the biases are very different types, and I can't tell you a lot because there hasn't been enough studies, but some studies, some unpublished work, right, from certain groups I know of, actually found very interesting biases between food items and gender in the context of Indian languages like Hindi. And you could imagine that other things like notion of privacy, notion of fairness, all these things are so cultural that all the current framework, which are mostly developed within the, I mean, using the Western notion of, let's say, privacy or fairness or bias, need not apply as is when it comes to building such technologies or frameworks for South Asia or India in particular. So these are all very, open questions, very fertile areas of research, and I wish just more and more groups in India start working on, India specific problems too, because there's a lot of scope here.
That's really curious. So I would, at least intuitively, I would have thought that perhaps Hindi embeddings would have fewer gender biases, just because it's like a gendered language. Um, but I mean, that's really interesting that that doesn't seem to be the case.
You are saying Hindi should have less gender bias because
Perhaps.
it's a gendered language?
Yeah.
See, if you think of it, right, why the doctor man and nurse woman bias happens in English? It's because the way we measure the bias is we take the distance of these words from, other gendered words like man, woman, which has a clear gender. Now, you could I mean, and that's because you would have text which always refers to, talks of some man who is a doctor and refers to with the pronoun he there and so on and so forth, right? And those can be used to measure these biases. Similarly, in Hindi, right, if this kind of a bias was there, so then there would be words like doctor and nurse in Hindi also. I mean, mostly we will use the borrowed terms doctor and nurse only. Uh, and then you would have associations like, admi, aurat, and then association like, the gendered verb, like you said, karta hai versus karti hai. If you measure, association of those words with doctor versus nurse, you could see a similar kind of bias. Could see. I'm not saying we see, because the point is, at least one study apparently showed that we do not see exactly similar kind of biases like profession related biases, which you see a lot more in English, but we see other kinds of biases. Like, I mean, it was very, very strange to me. Apparently, we see a lot of food item related biases. And one of my colleagues later then explained that it's probably because in India certain food items are related to men and certain to women. So for instance, लड़कियों को खट्टा खाना पसंद है. It's a very common gender stereotype, right? So when it comes to golgappe, when it comes to, achar and something of the pickles and those kind of food items, probably women is more associated with that, whereas men is probably more associated with kebab, tandoori chicken, biryani. I don't know. That might be the bias which was showing in the embeddings. So how fascinating is this, right? Whether it's true or not, and all these are different questions. But just because this kind of differences exist, and so striking differences between culture, which are reflected in these embeddings, is itself such a fascinating thing, and very few people have explored these things. That's the point I'm trying to make here.
Definitely, I guess that I was recently seeing the doctor versus man research, which you mentioned. And yeah, it would be interesting to see stuff like this in Hindi. Uh, but I guess we can spend a lot of time talking about these very interesting research areas. But due to the dearth of time, we would, if like, to shift to a bunch of career-oriented and general questions, so people who are listening can have a better understanding of, because there has this very sudden surgence of machine learning and data science, at least in the mainstream now, and a lot of people are getting interested in it. And we regularly see these questions of how is things going on, especially in industry, how to get there. So it would be great to know your opinion on it. To start with, maybe on a lighter note, how is like the research environment at Microsoft Research India? How does the research is different than maybe the product side of things, or how do they interlink together?
So, Microsoft Research started around 23 years ago, 23 or 28, anyway, doesn't matter, long time ago. And the philosophy with which it was based on um, was primarily that research should be, very independent and should not be tied to products. So this was the core philosophy, because of course there are also product driven research, but the whole point of research was to think ahead. So product teams typically think in short cycles. So it could be as short as 3 months, what I'm going to release in 3 months, or even if I talk of long cycles, you might think of 1 year ahead, maximum 2 years ahead, when you plan for what's going to happen. And especially in today's world, it has become, the cycles have become shorter because the technology is also evolving so fast, right? On the other hand, in research, the expectation from you is you are thinking at least 5 years ahead, if not 20. So that's what we call like really horizon 3 or long term planning or thinking. And of course we are not thinking of, not necessarily thinking of building products that will affect people 20 years ahead, because that might be a useless, I mean, I'm not saying altogether useless, but it's very hard to imagine what kind of products will be useful 20 years from now, right? But you are thinking in more general terms. How would human computer interaction look like 5 years from now with all the changes that's happening and you foresee? How would, let's say, social impact using mobile phones in India like countries look like 5 years from now, because number of mobile phones would have changed, number of people in the digital economy will change. So you take all these things into account and think about that things. And of course a lot of these problems also involve under asking basic science questions. So for instance, if you are trying to imagine what will happen 20 years from now, probably one thing you might think is quantum computing is going to be very important. So then you have to build the entire theory of quantum computing and push the state of the art in that field, right? And of course it has no products related to it today. So that is the primary philosophy of research at Microsoft Research, and therefore it's kind of dissociated with the products. However, this dissociation is only in a more philosophical term, right? Practically what you see is there is a loop that always goes on. We do things, we talk to the product teams look at the markets, they come back and tell us their experience, which goes in our research. So it's all very integrated, and when I say it's dissociated, it's only like in what the fundamental goals are, not in terms of how we work. We in general work very closely with product teams, and there are three broad, I would say, charters of the research labs. One is pushing the state of the science. One is, making an impact on the society. And the third is making an impact on Microsoft, which would be more like, helping Microsoft products. And all these three are equally important. And different researchers have, might have their own perspective on how they want to do it, how they want to balance between the three, etc., etc. So in one line, there is a lot of freedom. Apart from these three broad goals, nothing is specified. So you decide what is important according to these three metrics.
Makes sense. To move forward, I guess next question, this is going to be a very broad question, and I understand there is no one right answer for everyone, but still I guess this is a question which even I had think about a lot of times, and I have people ask us or around us a lot of times. So it would be great to know your opinion on this. Generally, when you guys are hiring at MSR India, or what do you believe is generally for data science kind of positions, when you're hiring, what are the markers you are looking for in the people? And do these markers change based on, let's say, background? So people like maybe me and Karmanya, who are coming from very conventional background of doing a undergrad, doing a PhD, and then applying to industry, versus I see a lot of people who have been software engineers for 5 years or developers for 5 years now, and are trying to segue into research or at least data science positions. So what are these markers you look for in the people, and how do these markers change from do they even change based on the background of people or not?
Yeah, a broad question indeed. Since you specifically asked about MSR, uh, because the way things work at Microsoft in general versus specifically in MSR are quite different. So in MSR, there are three kinds of positions broadly, right? So one are the researcher positions, and researcher positions are always, I mean, it's not set in stone, but almost always only after PhD. And since, like I said, the research is almost academic style research, so a PhD kind of training is very, very essential. Uh, of course, somebody might have a long experience in certain industry and the publications and everything. So even if the person doesn't have a PhD in pen and paper, still that person can be considered. So that's fine. But it's easy to understand that somebody with a PhD, whatever they will have, right, in a portfolio. So you'll have publications in top tier venues. You will have a people will recognize you as a thought leader. Now, of course, the expectation would change at the level of hiring. So if you are hiring a fresh PhD, you won't think of that person, you don't expect that person to be well known across the entire world. So but at least in their field, let's say this person works on privacy or certain kind of algorithms within privacy, and within that community this person's work should be well respected and well known. Whereas if you are hiring somebody at a much senior level, you would want that person to be well known across the world in the field. So that's more or less a broad characterization, I would say. Now, there are also hiring that we do at um, uh, another level, which we call research fellows. So these are 2-year positions for fresh undergrad or postgrad, mostly undergrads, who come and spend a couple of years in our lab before they go for the next endeavor. Mostly PhDs, but not necessarily so. Now, there it's a very different process. If you want to know more, I can tell more, but it's a very streamlined process, and we have around 30 to 40 people at any given point of time in our lab who are research fellows, and they bring a lot of student like environment, because I mean a university campus like environment, because they are very young and almost like the same age as master student or PhD students. So it's a lot of fun working with them. In fact, a lot of the work, heavy lifting, is done by them. uh, and then we have other kinds of roles, which are like, of course, engineering roles, which we call research software development engineers, and then we have program manager kind of roles. Now, the expectations from these two, research software development is still more easy to characterize, because there you would want a very deep experience in software engineering, and so that somebody can build softwares easily, uh, with a lot of expertise, and can bring in that experience there, right? But when it comes to program manager, that's a very, I would say, fuzzy role, because depending on the there are so many different types of projects and programs happening. So what kind of projects or programs you want this person to work with, you might want different kind of background. So here it's really open ended. But the number of positions there are also too few, right? So it's mostly researchers and research fellows, kind of two big buckets, and then RSDs.
Great. And I guess the last career question I would pose you is a very short one-line answer of, if you had to give advice to maybe a young undergrad or postgraduate student trying to get into NLP or linguistics research, what would be like one starting resource you would recommend, and what would be your one, so to say, golden tip he or she should take care of?
Um, Resource is a hard question, but a golden tip I can definitely give is, ask yourself whether you are interested in languages, understanding how languages work, what are different kinds of problems within languages, or linguistics, if I be more technical. So whether you are interested in that, and whether you are interested in helping the speakers of a particular language. If these are the two things which excites you, right, then NLP is certainly a field you should think of investing your time into. If not, if you are only interested in, let's say, the mathematical aspects, let's say machine learning and all, which is also fine, absolutely fine, I'm not judging here, but then you know I'm not sure if NLP is the field you should look at, or other applied fields, or just machine learning itself, right, as a field you should look at probably.
I guess that's a great advice.
Yeah, sorry, I'm just trying to think about that a little bit. Because I mean, I've always thought of myself as someone who's interested into NLP, and then, but of course, because I got into it from a very ML point of view, that's actually a question I've never really thought to ask myself. So I think that's really powerful.
And I guess that is the reason I have done a fair bit of NLP, but whenever it comes to research, that is, I guess, I never feel comfortable calling myself an NLP researcher, and that's where probably the whole segue of me ended up going to PK and joining a PhD under him was because the whole social part of it like attracted me a lot more, that what socially ended up happening to my research compared to what NLP technique I'm using. So I guess that way I made a fair choice.
Uh, Yeah, I mean, all the best, and I think you did do a good choice. And Karman, yeah, I don't want to discourage you definitely by saying this, and I think what I definitely don't mean is whether you have a background in linguistics or not. That's not the point I'm trying to make. Yeah. So to be clear, it's more about whether languages excite you or not, right?
Right. No,
Why something is happening in a language or how something is happening.
right. I definitely get that. It's just that, I mean, sometimes, you go down a path and then, like, very obvious things on that path don't, like, hit you. So I just want to, like, thank you for that question. That's really interesting. It's not something I thought about before. Um, I think the last thing we'd like to talk to you about is we were doing some research and we saw that you're involved in something called the Panini Linguistics Olympiad.
Right.
And to me, this seems something like completely left field, right? Because, I mean, growing up in India, I've heard of like computer science Olympiads and maths Olympiads and participate in all of those. Linguistics is like, I didn't think there was enough of a community in India to even warrant a linguistics Olympiad. So, do you want to like maybe talk about it a little bit?
Thanks for asking this question, actually. Yeah, Linguistics Olympiad is something which I'm really, really passionate about, and also proud that we have been able to pull up a program in India, which, in my opinion, has been quite successful. Uh, so. mm, Uh, let me tell what it is first, because like you said, most people don't even know even today, like even though we have been there for like 10 years now, not many people know about it. So it's like you said, it's like the science Olympiads. So there are these physics, chemistry, biology, astrophysics, astronomy, math, information sciences, programming, and all those kinds of Olympiads, right? There are 13 or 14 which are very popular ones. And linguistics is one of those 13 or 14 Olympiads, and which happens at every level. So it's like, in some sense, it's as serious as the math Olympiad. So it happens at regional level, then national level, then international level. And the international Olympiad is a lot of fun. I don't know if you guys have been to any of these international Olympiads, but it's fun because the top students from all over the world representing their countries come there and compete. And then there is so much excitement. It's almost like real Olympics. So one medal goes to a country and you all jump with the flag and all. It's very exciting, and so much social interaction happens. You make so many friends from so many different countries. Now that's about the structure. And the league, I wanted to mention the league at which Linguistics Olympiad is. The second thing I want to mention is what kind of problem do you solve, right? So people understand what is math Olympiad or what is physics Olympiad, right? What kind of problem to expect. The main issue in Linguistics Olympiad is, if I say Linguistics Olympiad, you won't guess what kind of problem to expect. And you might even think, you meaning the students or even the school teachers, they think that, oh, it's something we don't teach, we don't understand, or maybe it's literature. And when they look at the question, they see there is no literature here, so they don't know what to do with it. So it kind of falls through the cracks, right? Because schools do not have a linguistics program or curriculum per se. So that has been one of our biggest problem in popularizing it. So essentially what Linguistics Olympiad has is puzzles, analytical puzzles. You have a data given in a language which you don't know. Let's say some 12 sentences in a language which is almost extinct and spoken in Papua New Guinea. And then you have their translations given in English. And now you have been given 6 new sentences in that language and translate it into English, and vice versa. So this is typical structure of a problem. All these problems use some data from an unknown language. It need not be a natural language, it could be an encoding system. Like it could be, there are some mathematical encoding systems which people have come up with, or even biological, like floral diagrams is an encoding system of representing flowers which botanists use. So any encoding system where you use symbols to encode information, and the task is to decipher that encoding system. So in some sense it's all puzzle solving, and in the process you learn so much about languages around the world and linguistics. So it's a very, experiential learning. Nobody's teaching you anything. You don't have to go through any formal linguistics course or any book or anything. You just solve problems. If you are into puzzle solving, you love solving puzzles, this is for you. And how we do it in India right now, I mean, long story cut short. So we started in 2009, India started participating. 2013 is when I got associated. And then we tried pulling up a lot of universities, IITs, JNU, Triple IT Hyderabad is the main organizer right now. So all these organizations came together, and we have a network through which we design problems. And then there are centers around the country where the first level test takes place. We select a bunch of students, come to a camp where the second level happens. Usually it's in Triple IT Hyderabad, the camp. And then from there, we select a team of 8 students who go for the International Olympiad. Different years, it will be in different countries. In India, we organized the International Olympiad in 2016, 4 years ago. So this is typically the time when Linguistics Olympiad happens. So all my Facebook posts are full of, 1 year ago you were in Korea, or 4 years ago in Mysore, these photos, so on, memories. And I'm really missing. I think the entire community of Linguistics Olympiad is missing this year's Olympiad, which was supposed to be in Latvia, but because of COVID, of course, it got cancelled. But fortunately, we also do APLO, Asia Pacific Linguistics Olympiad, which I and few more colleagues from other Asian countries we have started last year. So this year I mean, it's kind of online, so people don't have to meet in a single country. It happens individually in their own countries. So even though, I mean, even with COVID, we can still host this Asia Pacific Olympiad. So at least something which students can participate in.
Okay, that's fascinating. I mean, I'm very curious as to how much you're taking the experiences from, say, virtual conferences and carrying that over to this Asian Pacific Olympiad, which is being held online. Are you finding like a lot of like parallels, or are you trying to like encourage corridor conversations a little bit and trying to figure out how that could work?
Not that much for Asia Pacific Linguistics Olympiad, because there the model is different. The model is, see, one of the biggest problem of Linguistics Olympiad is designing the questions, because the questions have to be very very hard, because it's an Olympiad, right? The brightest of the kids come and try to compete, so you have to give really challenging questions. But at the same time, the questions should not require any linguistic knowledge, and they should ideally use a natural language or some encoding system which already exists. I can't come up with my encoding system and ask them to decipher. It should be a popular meaning well established. Shouldn't be popular, because if it's popular, then students might already know the encoding, right? And then they don't decipher. So finding out languages which are spoken, I mean, which are not known to any of the contestant itself is difficult. So you have to go to, you have to get data from endangered languages which only very few people speak. So you don't expect a student coming in the competition speaking that language, right? So and it's international, so you can't use, in India when we run this test, we might use a African language, because I can assume no Indians would know that African language. But that's not true when you are doing an international contest. So coming up with the problems is very hard, and therefore what Aplo helps is come up with these problems, and it then takes the problem sets and distributes to individual countries, and then the individual countries conduct the test in their country and collate the result, check it, and send the marks to Aplo, and Aplo then declares a global, I mean, Asia Pacific ranking and marks. So it's a very asynchronous process, and therefore that conference models don't really apply here. But in IOL we did talk quite a bit about whether should we do it or not, and eventually it was decided that we are not going with a virtual IOL this year, because it's a competition. It's very difficult to ensure fairness. When the students are writing the tests, it's very, very difficult to ensure the fairness. So that's why we decided not to do an online contest.
Okay. I mean, that's fascinating. I think that's it. Thank you so much. Really, thank you so much.
Thank you so much. It was great talking to you.
No, it was good fun. See you.
Yeah, see ya.
Bye.
Thank you for listening to the ML India podcast. Your hosts were Hitkul and Karmanya.